Today we will be discussing related rates and optimization in Calculus 1. The first problem we are going to do is going to cover related rates. Aside from creating several highly successful businesses, Elon Musk has a passion for lime juice. He has taken a break from designing electrical cars and has decided to create the perfect lime juicer. Using only spherical limes, he puts them into a machine where a needle is inserted, extracting the lime juice and decreasing the volume of the spherical lime at a rate of 100 cubic centimeters per minute. However, once the radius of the lime starts decreasing at a rate faster than 1 centimeter per minute, the machine malfunctions. If Elon Musk puts a lime with a radius of 3 centimeters in his new machine, will it malfunction? At what rate will the radius be decreasing? So the first step is to draw a picture. And here we could see that if we draw a picture of this machine, we'll have a lime with whatever radius we want, and then the contraption will be extracting the lime juice into the container. So what do we have? We have dV over dt equals negative 100 centimeters cubed per minute. This is the rate at which the volume of the lime will be decreasing. And what do we want? Well, we are looking for dr dt when r equals 3. So this is at what rate the radius will be decreasing when r is 3, which is the radius of 3 centimeters, which is what we were given. So first we have to take the equation for volume of a sphere, which is v equals 4/3 pi r cubed. And then we take the derivative of this equation for the volume, and we get dV over dt equals 3 times 4/3 pi r squared times dr dt. Now we can simplify the fraction, plug in the radius for r, and plug in negative 100 for the rate the volume is decreasing. Negative 100 equals 4 pi times 9, which is the radius squared, times dr dt. So now we can isolate dr dt because that is what we are trying to find. When we do this, we end up with negative 100 divided by 36 pi equals dr dt, which turns out to be negative 0.88 centimeters per minute. Finally, we have to just solve with the context to the problem. Here we can see that when the lime has a radius of 3 centimeters, the radius will be decreasing at a rate of 0.88 centimeters per minute. This is not faster than the rate of 1 centimeter per minute, so the machine will not malfunction, and Elon Musk can enjoy the lime juice from this lime. Our second problem that we are going to do is going to go over optimization. Elon Musk has decided to make his own lime farm. He has 300 feet of fencing and 3 lime tree seeds. He wants his house to be one side of the area so that he can go inside his farm directly from the house. In order for the roots of each tree to not damage his house, the fence, or the other trees, each tree must have a radius of 25 feet that does not go past anything else. What dimensions should Elon Musk use to maximize the area of his farm and not damage anything in the process? What will be the maximum area? So first, it helps to draw a picture and see what exactly we are working with here. So here you can see that the side of the house is going to be one of the lengths, and then he has 2 widths on the other sides. Each tree in the middle will have a radius of 25 feet, and so a diameter of 50 feet for each tree. The first equation is for the area, and this is A equals length times width. The equation for the perimeter of his farm will be 2 width plus length equals 300, because he has 300 feet of fencing to use. So the width has to be at least 50 feet so that the trees do not damage his house or the fence. The length has to be at least 150 feet so that the trees do not damage the fence or each other. The first step we need to do is isolate a variable so that we could take the derivative with respect to said variable. We are going to be using the perimeter equation and isolating the width. When we do this, we get the width equals 300 minus L, all divided by 2. Now we can substitute this into our area equation. So we get 300 minus L divided by 2 times L equals the area with respect to L. Step 3, now we can simplify. When we divide 300 by 2 and we have 1 minus 1/2 L, we times all that by L, we will get 150 L minus 1/2 L squared. Now if we take the derivative of this, the 2 and the L squared will cancel out the 1/2 and the 150 L will just go to 150. So we get 150 minus L. In order to find the maximum area, we need to find the critical point, which is when the derivative is equal to 0. So we set this equation equal to 0 and solve for L. We get 150 minus L equals 0, which goes to L equals 150. Next, we have to verify that this is the maximum and not the minimum by using the first derivative rule. The slopes should be positive, then have a 0 slope, and then have a negative slope. This will make a concave down shape, leaving a maximum point. If we plug in the points 149, 150, and 151 into our first derivative, we could see that we have a maximum at L equals 150. Now that we know that we have a maximum at L equals 150 feet, we have to solve for W. Then we check the restrictions and then we can answer the problem. When we plug in L to the perimeter equation that we manipulated to isolate the width, we get W equals 300 minus 150 divided by 2. When we solve this, we get W equals 75 feet. And so now the dimensions we have are W equals 75 feet and L equals 150 feet. Next, we have to check the restrictions on each of these variables. So W has to be greater than or equal to 50 feet. And as you can see, it does satisfy this restriction. The L has to be greater than or equal to 150 feet. And here we can see that this does satisfy the restriction. With a length of 150 feet and a width of 75 feet, Elon Musk can use all of his friends to create the largest possible area. He will create an area of 11,250 feet squared, and he will have enough room so that the roots of each tree will not damage each other, the house, or his fence. Thank you for watching and have a nice day.